So let's take an example for each instruction. So first of all, we are discussing the format of what the instruction format of load. So LW is the instruction for loading the data from memory into register. R1 is the destination register. Offset is the value, the constant value. It is again a 12-bit constant value, immediate value that you specify. And R2 is usually contains the base address, okay, where you want to first jump into the memory, and offset would help you specify the access the particular element. Okay, so you could assume that offset plus whatever the value in register R2 plus the offset value makes the memory address, the complete memory address. Okay, so this corresponds to the complete memory address. Processor will go to this address, grab the data, and store it into register R1, whatever value you specify here. Understand? So this is the format, and you will see the format of all RISC-V instructions similar to having either two operands, two source operands, and one destination operand. Okay, just like an add instruction, add x1, x2, x3, or immediate instructions like two operands, one source operand and one immediate data, and then the destination register. We also have seen here also there are source registers, two source registers. One is representing the base address plus the immediate offset 12-bit value. When we add them together, the data is stored in R1. This is the destination register. In store, we have both source registers. How does it work? Is R3 corresponds to the value that you want to grab from register and put it into the memory. Where in the memory? R2 specifies the base address where you want to go in the memory, and offset specifies the particular location where you want to deposit that data. Okay? So load instruction LWR1, offset R2, again same. So here always remember we have a source register R2. We are reading the base address value from R2 and storing the results in R1. Here in store word, both of the registers are source register. Source means like it is acting as a source of data. You are not storing any value in these registers. So R2 corresponds to the base address in memory, and R3 corresponds to the actual value that you want to store in the memory. Okay? And this offset plus the base address is generally referred as effective address. So whenever I use a term effective address, you can easily understand that I'm talking about the offset plus the base address. Okay? And it is again, offset is always a constant value. It can never be a register. Just like in immediate instructions like add I or I, you specify the 12-bit immediate value. Similarly, offset is a 12-bit immediate value. So it's the 12-bit immediate value. The offset range would be minus 2048 to 2047. It's a signed 12 bits value. And again, you can see that what value you can represent in 12 bits is 1, 2, 4, 8, 16, 32, 64, 128, 256, 5124, and 2048. So the leftmost bit, 2048, always represent a sign. So minus 2048 to 2047. And this negative offset actually helps us jump from the base address either in the positive direction, either go up, or in the backward direction, go down. Okay, just like you can access any element with the help of negative indexes in arrays. Okay. Okay, so let's do this example first together, and then you will have an activity. Okay, so we have example C code, G equals H plus A 7. So what we are trying to do here is we are grabbing the 7th element of array A and adding it to H variable and then storing the results in G. This looks very simple instruction, but you are now going to see what happens actually behind the scene when you try to execute this instruction. Suppose that G corresponds to x20, H is in x21, the value of H is in x21, and the base address of A in x22. So again, I remember what is the base address. So what do you think? What do we need to do first? We have to perform addition. We have to store the value in x20, which corresponds to G. What will be the first instruction that we need? Loading? Yes, so load the data from memory because we have to read the value. And A7 clearly corresponds to some value, some array that must be stored in a main memory. Okay, so arrays cannot be stored in registers because we have only 32 locations in registers. Okay, so we only, and there are some registers which have some specific purposes, like x0 is a 0 register. Okay, so whenever you see an expression like this, you can clearly identify that it is an array or a list, and it must be stored in memory. So in order to read that memory value, you have to use the load instruction. Okay, so the compiled RISC code would be x22, which corresponds to the base address of A. 7 may be an offset to access the 7th element. Now the reason why I have highlighted is because this is incorrect value. I'll talk about it soon. And storing whatever the value at this location, we are storing it into x9, may be considered as a temporary register. And then x9 is added into H, which is x21, and the final results are stored in x20. Okay, so these are the two instructions which are executed. So A7, to access A7, what offset value should be used? What do you think? Yep.
Well, it kind of depends on the type of what your array is using. Like if your array is like, if each element is like a byte long and the offsets are in bits, then you need to like multiply it by 4, for example.
Okay. Yes.
Be 28 because each element in the array would be one word, so 4 bytes.
Yeah. So basically, both of you said the same thing. We have assumed that all the values, or whatever the value that we are storing, is represented in 32 bits. Okay. So it should be, the value should be 28 because A7 corresponds to the byte which is starting from this 28 byte. Okay, so 4 bytes, remember 4 bytes per word, so that is why we have to use, because we are specifying x22 corresponds to the base address of A. If I were to go back here, let me, yep, let me explain this first, and then, so A, let's draw A here, okay, and A, this corresponds to 0, 0th, which is, sorry, A0, and this is A1, and let's write addresses here, 0, this is 4, because every value is 32 bits wide, okay, and then 8, 16, sorry, 12, 16, and so this one, this corresponds to A0, 1, A2, A3, this is 4, 5, 6, 7, 8. So when we reach to a 7th location, it will be 28. So that is why we specify the base address, and x22 contains the base address. So let's say this is, instead of 0, it is 9000. So x22 will contain 9000, which will help us reach to this point in the main memory. Okay, once we reach to this memory, so offset is 28, which will be added together 9028, and we will reach to this point. So this data will be read, and is stored in the register which we specified. Okay? Okay, you were asking, yeah.
Yeah, is X9 just a placeholder?
Yeah, it's a placeholder. You can say it's a temporary register, and you can use any register, temporary register, if it is not specified. Any other question?